everyone, so I'm Lizzie and I'm a data scientist here at Split. So as a data scientist, I spend some of my time working on the statistical engine that calculates the results of our experiments, and also work with the team on promoting and encouraging best practices in experimentation, and generally just trying to make sure that we present the most accurate and the most insightful results possible. So as you might guess, as a data scientist working with an experimentation company, I'm a massive fan of experimentation. So I want to use some of my time today to talk about what exactly it is about experimentation that makes it so great and what you're missing out on if you're not experimenting. So I'm going to give some motivation for why it's absolutely worth investing the time to experiment with your ideas. But first, I'll take a step back and talk about how we got here. So where does this need for experimentation come from? Well, if we think about how engineering has evolved over the last few decades, we've moved from releasing updates to our software every year or every few years to now making incremental changes. So we're releasing new versions of our products every single day, or even hundreds of times a day. So we're releasing things and deploying way faster than ever before. But then, well, this naturally brings the question, with all this extra speed, are we actually delivering more value to our customers, or are we just shipping shittier software but shipping it faster? So this is where experimentation comes in, because it gives us a way to really answer that question. So when you adopt experimentation within your teams and your organization, it changes the way that you work, because it changes the way that you can define success. So rather than focusing on speed of delivery, so how many features you release each quarter, with experimentation, you can actually start to focus on the real value of those features. And you can really define success based on how your work impacts your end users and your customers and your business overall. And of course, this is what we care about at the end of the day. So experimentation lets us move from being focused on our output to really being focused on our outcome. And so this is why it's a hugely prevalent tool now. So the big tech names, they're all running tens of thousands of experiments each year. And I guess a lot of you here are going to be on social media in one way or another. So the chances are that you're in a bunch of experiments right now and you don't even notice it, just because experimentation is all around us. But as a technique, experimentation has actually been around for hundreds of years. So it's been around way before the internet even existed, let alone social media. The first documented experiment was actually run way back in the 1700s. This was by a doctor called James Lind, and he used controlled experimentation as a way to test and to prove that he'd found a cure for scurvy. And then we've got the t-test. So the t-test was actually developed over 100 years ago by a brewer from the Guinness factory. So it was used as a way to test and to perfect the way to brew Guinness. So then I'm happy to say that as well as fueling Split's data science team, Guinness is also what we can thank for this stats behind our experimentation. So cheers, Guinness. And then randomized controlled trials, which is kind of the modern version of experimentation, is actually credited to a medical research paper from many years ago. So my point here is that these techniques, they've been around for a really long time, and they're have brought around a lot of really great developments in science, and they're used way beyond just the way that we think of experimentation today and online optimization. So then what exactly is it about experimentation that makes it so powerful? One of the things that we often get asked is it really worth that extra effort of doing randomization, of going through all the rigor and the process of experimentation, and is it really that much different to just using analytics and kind of being data-driven in different ways? Well, yes, absolutely it is. So I'm going to use my time here to talk about some of the science behind its success and some of the fundamental aspects of experimentation that really make it so powerful. Okay, and then these are the four that I want to talk about today. There are plenty more, but I think these are four of the biggest and the most convincing arguments. So I'm going to go through them one by one. So firstly, experimentation gives us a way to remove the impact of external influences from our data. So there's always a whole bunch of things changing in the world all the time. So it could be something like news stories or current events, or new COVID restrictions coming in, or something as simple as the weather. So on a hot day, people are more likely to go outside and less likely to spend time on their laptops. So one of these seemingly small things, they impact our customers, and therefore they impact our metrics. So what this means is it's pretty risky to say, release a new feature today and then try and measure the impact of that by comparing last week's metrics to next week's metrics. And that's because When you see a difference, well, you don't really know if it's because of the thing that you did or if it's because of all the other things that are changing in the world and impacting your customers. But experimentation gives us a way to remove all these influences. And that's because with experimentation, we're testing both versions at the same time and in parallel. So this means that all the things that are changing in the world, they're impacting everyone in your experiment equally. So then when you do see a difference in your metrics, you know it's not because of this new thing that's changed in the world, but it's really because of that one specific thing that you're testing, that one thing that you've changed. Okay, and less though is due to noise. So that brings us to the second super powerful thing about experimentation. And that is that it gives us a way to distinguish between random noise and a real meaningful signal. So in this kind of data, there's always randomness. Your customers are always slightly different to one another, and you can never predict exactly how someone's going to behave. And to give an example of how this works and why this makes our life difficult, you can think of the kind of textbook example of flipping a coin. So if you flip a coin 1,000 times, you're actually very unlikely to get exactly 500 heads and 500 tails. So it's actually 2.5% chance that you'll get exactly the same number of heads and tails. So then this means that when you do see a difference, well, you don't really know if that coin is biased, right? It could just be due to chance. It means really that most of the time you do this little test, you're going to see some difference. So when you see a difference in your metrics, like most of the time, quite often, it's actually just due to noise, and it's not really a meaningful signal. So one of the key points of the statistics of experimentation is that it gives us a way to really distinguish between what could easily be explained by expected noise and variations, and what is a really meaningful signal that we can really trust and pay attention to. And it does this because rather than just measuring the overall outcome and the metric values, we measure other things. So we measure things like the variance in the metrics and what's the spread of the typical values between our users. And we estimate the shape of the distribution. And then we use those tried and tested techniques like the t-test to kind of distinguish between what could and what could not be explained by noise. So this is where the term statistical significance comes in. And so this is like a stamp of confidence that the thing that we've measured is really unlikely to have occurred just due to chance. So this classification, it makes it a lot easier for us to interpret our results because, well, when we see this, we know straight away that we can really trust that we have had an impact and it's not just due to randomness. And this also, it takes out some of the subjectivity of it. So we don't have to kind of decide if it's a big enough difference or what it really means. We just know straight away that we can trust it. Okay, and then talking of subjectivity brings us nicely to the third thing that makes experimentation really powerful. And that is that it removes human biases from the decision-making process. So there's a whole bunch of different cognitive biases that are all going to impact how we all think, how we perceive reality, how we interpret data, and how we make decisions. So you don't need to worry about reading the text on this little diagram here, but it's just an illustration of how many different things can subconsciously impact how we make decisions. So for example, there's recency bias. So this is the bias where we tend to focus on and overweight evidence that we've learned recently. Or there's a human tendency to see patterns in data when there's not really any pattern there. Or of course, there's the confirmation bias. So this is the bias where we tend to overweight and focus on evidence that agrees with what we already believe to be true, or what we hope to be true. So this is why experimentation is so powerful, because when we follow this rigorous scientific procedure, we know that we're cutting out all of these biases from the decision-making process. So potentially counterintuitively, when we remove our emotions and our kind of current beliefs from the equation, we actually can make way better decisions, and we can really hear the voice of our users more clearly because, well, we know that we've removed those biases and we are truly following the data. Okay, so then onto the fourth and the last point that I want to mention that makes experimentation really powerful, and that's that it gives us this ability to really quickly detect when something goes wrong. So when we get in the habit of releasing our features behind an experiment and using measurement with our feature toggles, we get this great safety net because we can quickly see when something goes wrong, and then we can quickly pinpoint exactly what it is that's causing that issue. And that's because with experimentation, we're able to measure things on a feature-by-feature basis. So we can look at only the relevant segment of users, or we can kind of drill down into only the people who actually saw that feature, and then compare it to a statistically identical set of people who didn't see that. So this gives us a much more precise and a much more accurate view of what's going on. And this image here, it depicts how this works. So it shows one particular scenario, but seen through two different setups. So one of the setups is the one on the right there in the blue box. This is what you would see if you had experimentation. And then the one on the left is what you would see if you could only look at your metrics globally. So you can't look at things on a feature-by-feature basis. And here, this particular example is showing a situation where you've released 3 features recently. And you're releasing them cautiously, so only 5% of your users see each of those 3 features. But unfortunately, it happens that one of those has a bug. So that's feature 2 here. It has a bug that means that 40% of all the people that see it run into an error or an exception. So here, if you didn't have experimentation and you just looked globally, well, all you can see is that 2% of your users saw an error. So, and that's because it's 40% of 5%. So this is a pretty small number, right? So it's going to be hard to see. It's going to be hard to distinguish out of the noise. You don't know anything about causality, and you don't know what the culprit is. You don't know what's causing this bug. So then when you do go and prioritize to look into it, well, you don't know where to start looking. But on the other hand, if you're releasing everything by an experiment, then it's so much better because you can see straight away that it's feature 2 that's causing the issue. You're going to see it so much quicker because, of course, it's easier to detect a 40% difference than a 2% difference. And because we're comparing to a statistically identical set of users, you have a lot more accuracy and confidence in that data. So in this way, when you release things behind an experiment, you can really reduce the time to resolve issues, and just in general, you get a lot more safety and a lot more confidence in your deployment cycles. Cool, so they were the 4 things that I wanted to mention, and I think altogether these things make it so valuable to release things behind an experiment and to use data to make your decisions and follow the scientific method. So just to recap, with experimentation, you can remove the impact of external influences from your data and from your metrics. So then when you do see a difference, you know that it really is due to that one specific thing that you changed. Experimentation gives you a way to distinguish between noise and a real signal. So this means that you can avoid that chance of making an incorrect conclusion and kind of being fooled by the data by thinking that something really happened when really it was just noise. Experimentation gives you a way to remove those subconscious human biases from your decision making. So this makes it a lot safer to make those decisions because you know that you're not subconsciously being influenced by your own desires to be right and to get that feature out. And then when you release things behind an experiment and when you use measurement, you get this great safety net because you can really quickly see when something goes wrong, you know exactly where to start looking, and then you can get that extra safety and confidence in all your deployments. Okay, so that's all I've got for you today. I hope I've convinced you that experimentation is a super valuable technique. Thank you, and I hope you enjoy the rest of the talks at Flagship.